You have to learn the thermal stability of carbonates as well. Carbonates, like first the reactivity series, we have potassium carbonate, sodium carbonate, calcium carbonate, magnesium carbonate, aluminum carbonate, because the carbonate valency is -2 and aluminum is +3, so we cross multiply, it will be Al2 CO3, the carbonate, and then bracket 3 for because of aluminum valency. Zinc carbonate, iron 2 or iron 3 carbonate, lead carbonate, copper carbonate, so again sodium and potassium carbonate, when we supply heat energy, the same trend, they are stable to heat. What's the meaning of stable to heat? Stable to heat means when you supply heat energy, you cannot carry out a chemical change. Physical change can occur, like potassium and sodium carbonate are white solid. When you supply, you can melt them. That can happen. But by supplying a heat energy, you cannot chemically decompose. So they are stable to heat in terms of thermal stability. From calcium till copper, again, it's easy to remember from C to C, like starting with calcium, ending till copper, ending at copper. And what will be the product when we supply heat energy to this carbonate? This will result in a formation of metal oxide plus carbon dioxide. So supplying heat energy, the results will be calcium oxide. Like example, if we have calcium, we are decomposing this calcium carbonate. So as a result, it will be metal oxide, means calcium oxide, plus carbon dioxide. If we supply heat energy to lead carbonate, what will be the result? The result will be lead oxide plus carbon dioxide. And mercury, silver, and platinum do not exist. Or even if a compound exists, it is a very short in time it can exist because the compounds are not stable. So by themselves also they can decompose instead of we supply the heat energy. You have to learn the color change in only for calcium part. Like when we supply heat energy, when we have calcium carbonate and we supply heat energy to calcium carbonate, it decomposes to form calcium oxide plus carbon dioxide. The color of copper carbonate, when we supply it, turn into copper oxide plus carbon dioxide. So color of this copper carbonate, it is green in color, and copper oxide is black in color. So the observation, the green copper carbonate turn into black solid, copper oxide is a black solid, and it will give a colorless gas which will turn lime water milky. Is it clear? The thermal stability of the carbonates.
Sir, I have a question.
Yes, sure.
Sir, this is for copper with the valency of 2 plus, right?
Yeah, copper with a valency. There's copper plus one as well.
Okay, what about that one? Should we know the color change for that?
No, only because copper, the transition element is a transition element. Copper can be plus one, can be plus two. So you just have, you're only throughout the course, you're learning only a compound with a valency of a copper plus two, not copper plus one.
Okay, sir. Thank you.
And there's one table which I will share with you so you can know the color of the compounds from that table as well. Then take the screenshot. The last one is the thermal stability of the nitrates. Nitrate means NO3, and the valency of the nitrate is -1. So thermal stability of the nitrates, potassium and sodium. This time the nitrates are not stable to heat, it can decompose. And again, from calcium till copper, the same order is there. Now, what is the result when we supply heat energy to potassium or sodium nitrate? This will form metal oxide, metal nitride plus oxygen. So, what is metal nitride? When one oxygen is less in nitrate, we call nitride. So if potassium nitrate, when I supply heat energy, it will form potassium nitride. I'm not writing a balance equation. Balancing part we'll discuss, but I'm just completing a product. So it will decompose into potassium nitride plus oxygen. Same thing if I supply heat energy to sodium nitrate, this will result in a formation of sodium nitride plus oxygen. From calcium till copper, when we supply heat energy, what will be the result? The product, when we supply, it will decompose to form a metal oxide, nitrogen dioxide plus oxygen. This nitrogen dioxide is a brown gas. This appearance of this nitrogen dioxide, that's a brown gas. So you will observe if you decompose any of these nitrates, a brown gas is released. Observations are always important. Like you should know like what you will observe for a certain chemical reaction. So when I supply heat energy to magnesium nitrate, what will be the result? Magnesium oxide plus nitrogen dioxide plus oxygen. Again, the equations are not balanced. I did not balance any of the equation. It is just I'm completing equation for the product form. So when we supply heat energy, it will form copper oxide, metal oxide plus nitrogen dioxide plus oxygen. And this time, like mercury, silver, when we supply heat energy, this will result in a formation of a metal plus nitrogen dioxide plus oxygen. So when we supply heat energy, example to silver nitrate, so it will result in a formation of a silver metal plus nitrogen dioxide plus oxygen. So this is a thermal decomposition of the nitrate. When we heat potassium and sodium nitrate, decompose into potassium nitrite and oxygen, or sodium nitride and oxygen. When we supply heat energy to metal oxide or metal nitrate from copper till calcium, it decomposes to form metal nitride, metal oxide plus nitrogen dioxide plus oxygen. And the least reactive metal, such as like silver, is there, decompose to form a metal plus nitrogen dioxide plus oxygen. The last three this time exist. It was not existing for carbonate and hydroxides. So you don't find these hydroxides or carbonate, but you find nitrate of these compounds. Which compound you think will decompose at a very high temperature? Potassium nitrate or platinum nitrate? Which compound you think will decompose at a very high temperature? Which compound you think will decompose at a very high temperature? Yeah, because more reactive metal, their compound are stable. So this will decompose at a very high temperature. You need greater amount of heat energy to decompose. Relatively low temperature, you can decompose this compound. Because the thermal state, I told you in the beginning that when we compare the stability of the compound, the more reactive metal, their compound are more stable. So it decomposes at a high temperature. Now, to balance the equation, this table you have to learn. Like example, if you want to balance equation, potassium nitrate decompose to form potassium nitrite plus oxygen. So whenever we want to balance, we always start with oxygen, followed by hydrogen, and then the other elements. So first thing, you have to balance oxygen. So and I have 4 oxygen on my right hand side, and I have 3 oxygen on my left hand side. So what I can do, I can put 2 here. If I put 2, now it makes 6 oxygen. I have to make 6 oxygen. So how I can make 6 oxygen? I can put 2 here, that will make 6. But the thing is, because this 2 is with potassium as well, so which side I will place a 2? Because if I place 2 here, oxygen will be balanced. If I place 2 here, oxygen will be balanced. But which side I should place a 2? Because I'll place with potassium nitride. Reason for that, as we know, potassium is also 2. So this will balance the potassium as well and nitrogen as well. So you can see this equation is balanced in terms of potassium, in terms of nitrite. Is it clear? We started with oxygen. When we check oxygen on our left hand side, we have 3 oxygen. On the right hand side, we have 4 oxygen. So I can increase the oxygen number by putting a 2. 1 is already there, so I put 2. When I put 2 here, the oxygen is now 6. So I have to make 6 oxygen. I can write 2 here, that will also make 6 oxygen, or I can write 2 here, that will also make 6 oxygen. But which one I should write 2 with? I should write 2 with potassium nitride. Reason for that, because when I put 2 here with potassium nitride, the potassium is also balanced and nitrogen is also balanced with this 2. So and now you can see this equation is balanced in terms of nitrogen, potassium, and oxygen. Is it clear? This balancing. So the balance, this is a balance equation. So if in exam, the question is there like completing a product. So it will be potassium nitrate gives potassium nitride plus oxygen. That's 1 mark. But the second mark is the balancing. Same way, if you want to balance this equation, calcium nitrate decompose into calcium oxide plus nitrogen dioxide plus oxygen. Now I want to balance this equation. First, balancing start with oxygen. 3 multiplied by 2, 6 oxygen. I have 1, 3, and 2. So total will be 5. I want to make 6 oxygen. So what I will do, I will put 2 here. So oxygen is balanced. So this equation is balanced. You can see 2 oxygen, 2 oxygen and 2. So total 6 oxygen. Oxygen is balanced. What about now if we try to balance calcium? How many calcium are there? 2. So I will put 2. So calcium is also balanced now. But when I put 2 here, again the balancing of oxygen is disturbed. How many oxygen now? 3 multiplied by 2, 6. Multiplied by 2, 12. So we have 12 oxygen. And how many oxygen here? 2, 2, and 2. So we need 12 oxygen. So what I can do, if I put a number, I cannot put any number with nitrogen and oxygen. Reason for that, because you can see here how many nitrogen are there. This is 2 multiplied by 2, 4. So if I put 4 here, so all are balanced. 4 multiplied by 2, 8, 9, 10, 11, 12. So total 12 oxygen on the left hand side, 12 oxygen on the right hand side. 2 calcium on the left hand side, 2 calcium on the right hand side, and 4 nitrogen on the left hand side, 4 nitrogen on the right hand side. So this equation is balanced in terms of calcium, nitrogen, and oxygen. So 1 mark is for completing the equation and the second mark is for balancing the equation. And right, is it clear? The balancing part. Why I put 4 here? Because I know nitrogen 2 multiplied by 2, 4. So I should put 4 here to balance nitrogen. So when I try to balance this nitrogen, the oxygen is also balanced. Now try to balance this equation. A similar equation, zinc carbonate or zinc nitrate decomposed into zinc oxide plus nitrogen dioxide plus oxygen. Balance this equation. Yeah, that's right. It is 2 zinc nitrate gives 2 zinc oxide, 4 nitrogen dioxide and oxygen. Because it's a similar equation, and here it was zinc nitrate ZnNO3, bracket 2 was there. I did not put bracket 2, but it is bracket 2. Because zinc nitrate is there, zinc valency is. There was a bracket 2 with zinc nitrate because the zinc valency is +2. That's why it is ZnNO3 in a bracket and then 2. Okay, then if you want to balance another one, aluminum nitrate, you have aluminum nitrate, AlNO3 in a bracket 3. This decomposed into aluminum oxide, Al2O3 plus nitrogen dioxide, NO2, plus oxygen. What will be the balance equation for thermal decomposition of aluminum nitrate? It forms metal oxide plus nitrogen dioxide plus oxygen. I want you to balance this equation. Yeah, what could be the balance equation for this decomposition? So 4, 2, 12, and 3. So when you check oxygen, 3 multiplied by 3, 9 multiplied by 4, 36. Oxygen, when you check on the 3 multiplied by 2, 6 plus 24, 30 plus 6, 36. So oxygen is balanced. What about aluminium? You have 4 aluminium, 4, that's balanced. What about nitrogen? 3 multiplied by 4, 12, and you put 12 there, so nitrogen is also balanced. Is it clear? This balancing of aluminum nitrate. Now some questions. Three students X, Y, and Z were told that solid P react with dilute acid and also conduct electricity. The table shows a student suggestion about identity of a P. Which of the students are correct? Question 2. What could be the answer? Everyone should participate, show the understanding of the topic. What could be the answer? Yes, C is the right answer. Look, how you conclude it is C, because as they mentioned, it was reacting with dilute acid. Copper does not, if you remember the reactions, The copper does not react with dilute acid, it only reacts, so it cannot be copper. Graphite, carbon is there, no reaction, so what we are left with? We are left with iron. Question 6. What's the answer? Thermal decomposition. What will be the product for decomposition of metal nitrate, magnesium nitrate, and magnesium hydroxide? So when we supply heat energy to metal nitrates, they form metal oxide plus nitrogen dioxide plus oxygen. And for hydroxide, it will form metal oxide plus steam. A is the right answer. Question 34. What could be the answer for question 34? So all metals can conduct electricity. All metals are not hard, as we discussed group 1. They are soft metals, can be cut by a knife. Low melting point. Not all metals have low melting point. Not all of the metal react with water. Question 37. What could be the answer for question 37? Look, first thing, how you'll identify when there's a metal nitrate of a Q, it's a white solid, so means group 1, 2, or 3 is there. And effect of heat, because normally nitrate decompose to form metal oxide plus nitrogen dioxide. So brown gas is there, but colorless gas is only given off when you supply heat energy to potassium nitrate, because this will form potassium nitride plus oxygen. And you supply heat energy to sodium nitrate, it will form sodium nitrite plus oxygen. So both cases, the colorless gas is oxygen, that's why. So the Q can be potassium or sodium. And their nitrates or carbonates are stable to heat, so this confirm this can be potassium or sodium. What about nitrate? Brown gas is released, so it can be from copper till calcium till copper. But the thing is, their appearance is white solid. So if it is white solid, it cannot be copper. It can be any other. So why it cannot be copper? Because it's a white solid and copper is a transition element. So its compounds are not white solid. It form a colored compound. So what is the right answer? D is the right answer. Is it clear how we identify? Because Q can be potassium or sodium. So A and B cannot be answer. You're left with C and D. But how you will identify whether it's a copper carbonate or calcium carbonate? Both decompose to give a brown gas. But the thing is appearance. Copper compounds, they are not white solid, they are colored compound. Group 1, 2, 3, they are white solid. So we conclude that the right answer is D. Is it clear? That's why the appearance was given, because without the appearance you cannot identify. Both of them decompose in the same manner, but copper compounds are colored compounds, whereas calcium is a white solid because of group 1, group 1, 2 or 3 compounds.